Okay, so after getting the combined heat transfer coefficient or yung H, can now solve for the rate of heat loss per meter of pipe length. So we have here our pipe and we need to compute the heat loss given by these Q's per meter length of this pipe. Okay, so to solve for B, heat loss per meter, we can now use the equation Q is equal to H A delta T, right? And we can further express this by having our A or our area can be written as the circumference, which is 2 pi r times the length and the delta t. Okay, so for us to get the heat loss per meter, we can now divide this both sides by unit length. Okay, so having that, we have Q over L is equal to H, and our 2R is D. Okay, so we can rewrite this as pi D delta T. Okay, so this Q over L here, we can use the symbol Q prime. Okay, so our heat loss per unit meter here is just equal to this equation. So H times pi D delta T. Okay, so our H, our combined heat transfer coefficient, is already computed, which is equal to 33.9 watts per meter square K, and then multiplied by our pi. Then the diameter of the pipe is, I think it's 0.5 meter. So the diameter of the pipe is 0.5 meter. And our delta T is from the surface, which is 500 and 300. So we have the T surface 500 minus the T room is 300. So we have 500K minus 300K. So all in all, our heat loss per meter length or per unit length is given by this equation. So 33.9 times pi times 0.5 times 200 is equal to 60,650 watts per meter. So as you can see here, our heat loss is per unit length. Okay, so all in all, our heat loss per meter length of pipe is 60,650 watts. Okay, so that's all. Let's review. So this is our problem. We have this given 0.5 meter diameter pipe length with emissivity of 0.9, and then the temperature of this pipe is 500 K, which is exposed to the room temperature of 300 K. Okay, so there's a heat transfer between this um, hot surface of the pipe and the room. So we have here the heat transfer coefficient between the surface and the air is 20. So we can first need to know the combined heat transfer coefficient because there's a combination of convection and radiation going on. Okay, so the formula for that combined heat transfer coefficient is given by this, and we can directly compute the value of H because HC is already given, which is 20, while HR can be computed using this equation. Okay? And by having that, we can now add the two and get the combined heat transfer coefficient and proceed to the Q loss per meter. Okay. Uh, and using our main heat transfer formula for convection, so we have Q is equal to HA delta T, but we need to determine the per unit length, so we expand the formula of our area, which is 2 pi r times the length, and dividing both sides by length, we can now get the heat loss per unit length. And substituting those given values, you can now get the value of 60,650 watts per meter.